So today we're going to have some fun with LCM and HCF and do some interesting problems. So here's an interesting problem. A number is 12 factors, two of which are 6 and 27. List all the factors. Now I don't know whether you can actually do this problem or not, but let's start trying. So we know, let's assume that the number is something. Let's call that number x. I don't know what that number is, but let's call that x. So x is one of the factors of that x is 6, which really means that x is a multiple of 6. Okay, so I can write it as 6 times a. Okay, but I also know that 27 is a factor of that number. So that means I can also write x as a multiple of 27, because 27 being a factor of x really means x is a multiple of 27, and similarly 6 being a factor of x means x is a multiple of 6. So now, but there's something that you have to worry about. X may not be the least common multiple. It is a common multiple of 6 and 27, but it may not be the least. Okay, that's important to remember. Okay, so now let's look at the prime factorization of 6. We can certainly do the prime factorization of 6. 6 is just equal to 2 into 3. We know 27 is equal to 3 cubed. So that's easy and enough to do. We know the prime factorizations of this and 6 and this. Now note, since x is a multiple of 6 and is a multiple of 27, so it must contain 3 3s and 1 2 at least. It may contain more. So this implies that x must contain at least, it may contain more stuff. So all the more stuff, I'm going to call it n. I don't know what that is, but it must contain 1 2 and 3 3s. Why is that? Because if it does not contain 3 3s, if it does not contain 3 3s, it can't be a multiple of 27. And if it does not contain 2, it can't be a multiple of 6, because 6 contains a 2. So you must have a 2 and 3 cubed. It can contain more stuff if it wants to. So now we know 3 cubed times 2 is 54. So that means x is some multiple of 54. So let's look at multiples of 54. Well, the possibility is that x could potentially be equal to, so this is something that we don't know. X could be equal to 54 when n is 1. It could be equal to 108, or it could be equal to something bigger than. It would turn out to be 154 times 3, which would be, so this would be 1 times 54. This would be 2 times 54, and this could be another number, which is 3 times 54. And what's 3 times 54? 4 3s are 12 and 150, so 162, and so on and so forth. Okay, so x has various options. Which one is it? Let's look at factors of 54 and factors of 108 and factors of 162 and see which one has 12 factors. So if you look at factors of 54, so 54 is equal to 1 times 54. It's equal to 2 times 27. It's equal to 3 times 18. It's equal to 6 times 9, and that is where we stop. No more factors. So this has how many factors? Let's count. It has 1, 2, 3, 4, 5, 6, 7, 8 factors. So that doesn't work. So let's try another. Excuse me. The next number, which is 108. So let's look at factors of 108. It's going to be 1 times 108. This is going to be 2 times 54. This is going to be 3 times 36. It's going to be 4 times 27. It's going to be 6 times 18. And it's going to be 9 times 12. So all of these turn out to be 108. So let's start counting. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bingo! The answer is 108. So the mystery number is 108, and we have managed to solve the problem. So the number that has 12 factors, two of which are 6 and 27. If you want to list all the factors, well, all the factors are right over here. 1, 2, 3, 4, 6, 9, 18, 27, 36, 54, and 108. These are all the factors of that mystery number. Okay, so the trick really was to um, appreciate the fact that x may not be the least common multiple, but it is a multiple. And that's what this statement was saying. That this statement right over here was stating the fact that x is a common multiple of 6 and 27, but may not be the least common multiple. And that's what allowed us to figure out the answer to this question. Now let's try another fun question. So here's another fun question. So so we have to find all values of a number n. So what are the possible values of n such that the LCM of n and 6 is equal to 60? Okay. So again, let's start working and see. We can do the prime factorization of 6. So we know the prime factorization of 6. That's fairly easy. 6 is just 2 times 3. And I need to find out what n is. Now, please note that if you look at 60, I can also do the prime factorization of 60. It's just 6 times 10, and 10 is 2 times 5. So the prime factorization turns out to be 2 squared into 3 into 5. That's the prime factorization of 6. So here we have, so we have done the prime factorization of 6 and 60. So now let's think about what can n be. Now here's a potential for n. N can be equal to 2 into 5. Can it be 2 into 5? So let's think about it. Remember, we always pick out the highest power. But if I pick out the highest power of each of the prime factors, so if I'm trying to calculate the LCM of n and 6, and n in this case is 2 into 5, and this is 6, so the highest powers, so the LCM will turn out to be not equal to 60 actually. So if I take the LCM of 2 into 5 and 2 into 3, the LCM will just be 2 into 3 into 5, and that's what I don't want. It just turns out to be 30. So this does not work. Okay, but what does work is if I'd chosen n to be 2 squared into 5, then if I look at the highest power of 2, so I'm comparing these two guys, 6 and n, always. So if I look at the highest power of 2, it's 2. The highest power of 3 is 1. And the highest power of 5 is 1. That gives me exactly 60. So that will work. 2 squared into 5 will work. There's another n that will also work. So just pause and think for a second. Is there another n that could work? So think about it. N can also be another number. What could it be? Well, surely it would be 2 squared into, and I want you to really think about it. You see, I can't have an n which doesn't have a 2 squared because you see, right over here, I need a 2 squared to get to 60. So n and 6 only has one power of 2. So I need 2 powers of 2 in my n. That's a requirement. Similarly, 6 doesn't have a 5, but 60 has a 5. So I need a 5 in my n squared. That's not an option. But now note, so 2 squared times 5 must appear in n. But there is an option. What's the option? The option is that since 6 already has a power of 3, so if you look at it, 6 already has a power of 3. So right here, 6 has a power of 3. So it's really my choice whether I want to put another power of 3 in n or not. And in one n I did not, but in this n I could. And these two n's would work out and give me the LCM as being 60. So this is actually equal to 20, and this is actually equal to 60.